My name is Robert Matescu, and I was a postdoc in Shuki's lab. It is my distinct honor and great pleasure to introduce our next speaker, Professor Judea Pearl. He is Chancellor's Professor of Computer Science and Statistics at UCLA and Director of the Cognitive Systems Lab. Professor Pearl is widely recognized for his foundational contributions to artificial intelligence, spanning three major areas: heuristic search, probabilistic reasoning, and causal inference. First, his early research focused on heuristic search, using rules of thumb to explore alternatives and rolling back signals to guide decisions, a foundation for AI planning. Second, he introduced Bayesian networks and belief propagation, creating a framework for reasoning under uncertainty that deeply influenced AI and machine learning. Third, he developed a formal theory of causality and counterfactuals, a language and calculus for reasoning about cause and effect. Professor Pearl is a fellow of AAAI, IEEE, ACM, the American Academy of Arts and Sciences, and numerous other distinguished organizations. His contributions have been recognized with many honors, including the Turing Award, the Ichkai Research Excellence Award, and the BBVA Frontiers of Knowledge Award. But beyond the technical achievements, there is something else that stands out in how Judea talks about science. He often recalls his early education in Israel, where science teachers taught not just formulas and results, but the human story behind them. Theorems came with names and faces, and with them, the questions, struggles, and breakthroughs that shaped their time. While auditing Shuki's celebrated IST4 class, I experienced something similar, where he would pause to highlight the people behind the ideas, their motivations, their challenges, their victories. That approach gave students more than knowledge. It gave them a sense of connection to the ongoing story of science, as if Pythagoras or Shannon were in the room with them. Today, we are part of that same tradition, not imagining a distant voice from history, but hearing directly from someone whose work continues to shape the foundations of our field. Please join me in welcoming Professor Judea Pearl.
Thank you, Robert, for such a wonderful introduction. I'm extremely honored to speak at Caltech again. I think I talked here about 15, 16 years ago, and it always gives the shiver in my spine to think that I'm talking at the same place that is associated with Robert Milken and Richard Feynman. And it's doubly honor for me to speak in honor of my friend Shuki, who for many years I've tried to recruit to our one and only Hebrew choir in Los Angeles, and with whom I share. He's also a winner of the Feynman Prize for teaching, and we have something in common, and this is the admiration for Babylonian science and appreciation for the method, for the scientific methods, and as Shuki put it, is a love for ignorance. Am I right? Yeah. So the reason I chose this topic is also due to my love for ignorance. And normally in our field, we say if you want to learn a topic, then you volunteer to teach it, right? And in this case, I said to myself, I want to learn this topic. I'll promise Shuki that I'll speak about it. Okay. And that will force me to organize my thoughts and collect my scattered idea and encode them in slides. I'll be happy to show you the slide and ask you to evaluate whether they are well ordered. And there's another reason, an urgency in choosing this topic. You'll be surprised, but a week ago I got a phone call from a congressman, Bradley Sherman. I don't know if he represents this district, he represents mine. He heard that I'm doing AI, so he called me and said, we congressmen are extremely worried about the possibility that computer will attain free will, and that, according to the theory, will be the end of humanity. What do you think? I mean, when will it happen, and will it end humanity? Well, I hope I can convince you that it's not going to be the end of humanity, number one. And I will not predict here when it will happen, but I will try to convince you that in some sense, computers already have free will. Okay. In the sense that my job will be to explicate the sense in which computers do have free will. So let's start, I'll give you the outline. The outline is step by step will be first philosophical background, which is a history of zero progress scandals. Free will has been in the mind as a puzzle in the mind of all mankind from the time they invented the idea of God, omniscient God. And it's a scandal because they haven't done a single progress, a single step of progress along this puzzle. And this is not my words, but the names of philosophers. Okay? That's why they call it a scandal. Then we go from omniscient God to deterministic machine, where the problem is become more acute, more puzzling, and more inviting for solution. After all, we know computers, right? So we should be able to solve the puzzle, but it's still not totally resolved. And we'll ask about the computational aspect of this illusion. I call it illusion because if God knows everything, if the brain is a deterministic machine, then all our choices are predetermined by the neural activation inside our brains. We have no choices. So how come I do have a very vivid sensation that I have the option of touching my nose or not touching my nose? How many of you have the same sensation? All of you, good. So we are on the same page then. It is a puzzle, right? Because some people try to resolve it and say, our brain is not a deterministic machine. Okay, done. We have a quantum uncertainty here, or all kind of divine forces there, which will explain it. But it is a puzzle if the brain is a deterministic machine and if you believe in Laplacian physics. Then we ask the question about why has evolution labored so hard to equip us with this illusion? If it's just an illusion, evidently it must have some survival value. Okay. In which case, there are some speculation, and I'll give you three of them of why I believe it has a survival value. We'll see that it has, these are names for element of survival, aspect of survival: moral responsibility, play, credit, blame, and punishment, set priorities in our explicit representation of knowledge. And that is one of the idea. And then it also offers efficient communication and team performance. I'm now into free will. Yeah, good. So, as I told you, philosophers named it the greatest scandal in philosophy. If everything is predetermined, how can we have choices? It started with people who believed in God. Actually, Epicurus did not believe in God. So, you know, Epicurus is for us is a name for heresy. At least in Israel, when you say you are Epicurus, it means that you don't believe in God. But he tackled with the problem, and he came with the conclusion that the idea of predetermination is false, and there's no determinism in the world. The world is just an unpredictable swerve of atoms that breaks causation and allows for genuine free action. So there's no puzzle here. If it's just a random chaos, there's no puzzle of free will. And there's no scandal. He was a great man, actually, because he did other contributions, but I will not elaborate on that. Then came the opposite, Stoic, which said, on the contrary, God exists, and He set things, and if you want to live a happy life, just let things go. Be part of nature. Okay. The cosmos is governed by fate or necessary order, and freedom lies in our internal ability to choose responses, which makes us morally responsible. Relax. Don't try to control what is beyond your control. For instance, your health. Don't try to intervene. Your reaction to people around you. Let things go, be part of nature. You'll be okay. So that's the opposite direction. Okay. And then came Aristotle. We all know about Aristotle. He didn't make much of a contribution, but he at least distinguished voluntary from involuntary actions and talked about moral responsibility, that it depends on our voluntary action. We all know that you and I can distinguish between voluntary action and involuntary action. He made it not formal, but as formal as his time would permit. And, no, I have another one. Oh, I pressed incorrectly. Good. Aquinas was a Christian theologian in the 13th century. He didn't say much like most theologians. They just repeated what the Greek philosophers said, but cast it in theological vocabulary, so it will sound more captivating or convincing to the people of the time. Okay? So he talked about, repeated Aristotle, and said that divine knowledge is non-causal. It's some sort of knowledge. God knows what we're going to do, but it's not causal. Okay? I'll go now to the Jewish aspect, because the Greek gods were not really gods. They were a crazy bunch of anthropological metaphors of God. Some gods and demigods and cyclops and sirens and satyrs having orgy on Mount Olympus and drinking nectar and eating, what was the name? Ambrosia, yeah, ambrosia, okay. You wouldn't trust gods like that to control your knowledge, okay? So let's go to the kind of God that we have recognized in our conception, which comes from the Jewish tradition. It's monotheistic. The gods no longer fight with each other. They don't envy human beings. They don't try to marry human beings like the Greek God, okay? So this is the kind of God we can trust. So, so let's see what the Jewish tradition says about the puzzle. And here, first of all, here we have a statement in the Bible, in Deuteronomy, saying, "Beware, I set before you today a blessing and a curse." So you have a free will, right? Right there. And then it also said, God knows the knowledge of humans. In Hebrew, it says, Judea da'at elyon. The Almighty knows what you know. He knows all knowledge. Okay. So how do you reconcile the first with the second? Here comes a guy by the name of Rabbi Akiva, and says, very famous in Hebrew, Hakol tzafui vehareshut netuna, which means everything is foreseen, but still permission is given. You have permission to do good or bad, even though everything is predetermined, okay? Rabbi Akiva, by the way, let me go. Maimonides sometimes is credited with this saying. In my book, The Book of Why, I gave credit to Maimonides, and Hakol Tzafui V'Hareshut Netuna was the title of one of my chapter. But then when the book was translated into Hebrew, the editor caught it and said, no, it wasn't Maimonides, it was Rabbi Akiva. It so happened that I was born in Bnei Brak in the street called Rehov Akiva. And so I was very fond of the transformation, to change the credit from Maimonides to Rabbi Akiva. But notice what he's doing here. He's not trying to resolve the puzzle. He just repeats the puzzle in a four-word proverb. He doesn't resolve it. Hakol tzafui, which means everything is predetermined, and you still have the permission to choose good from evil. Okay? It's not a resolution of the problem. It's just affirmation of the puzzle. Then there should be giving credit to another guy called Ralbag or Gershonite, is Rabbi Levi ben Gershon, who was a mathematical genius in the 13th century, and among other contributions, he took it seriously, and he came out with the following resolution. God knows only possibilities, a set of options, but not the options you're going to take. And the Lord, he knows that, and he knows the Lord governing them, but not man's choices. He doesn't know that. Look what he's doing. He is minimizing God's knowledge in order to resolve the conflict. By the way, he's credited for being the first to apply mathematical induction in Europe. okay, although it was done by a Persian author, I forgot his name. But he was the first to independently invent it and publish it in Europe. So that is a compromise. Okay. Let's go now and see what happens more recently. We go now from God to science. It's still the greatest scandal in philosophy, but now the thing which is predetermined comes not from God, but from the rule of physics. According to Laplace, and I'm going to give him great credit here, he changed the whole perception about choices and about determinism. And his conception was that the world is fully deterministic. The free will is just an illusion. The uncertainty that we experience is just a matter of being ignorant about the boundary conditions. Otherwise, if you give me the boundary conditions, I can calculate everything that was and everything that will be. And in his word, he said the present state of the world is an effect of the past. And it is the cause of everything in the future. Okay? Which means if you give me the position and momentum of every molecule in the world today, I can predict everything that happened in the past and everything that will happen. Therefore, there is no choice. There is no free will. And he indeed said so explicitly. There is no choice. He didn't have quantum mechanics, but he said, if my brain is deterministic, then I have no free choice. Everything is already encoded by the laws of physics, by the past, and that's it. It's only it's becoming free will is an illusion. I would like to give some credit to Arthur Schopenhauer, although it may be too long. He was a funny man. Totally, he was scared of women and scared more than women. He was scared of men. Oh, he was. I'm sorry. Yes, and he had, I think, 4 poodles that he liked more than anyone else, and his contribution was in the way he looked at the problem. And he said, our will is determined by prior causes. Okay? Man can do what he wills, but he cannot will what he wills. Okay? I like it only because it has recursion. And recursion here is important because it will come out later when we talked about the Turing-Halting problem, okay? Or self-referential. Okay. No, that's wrong. This is the right button. Okay. Now we come to the more modern area. When computers came into the consciousness of scientists and as a metaphor for thinking. And here there is an important group of philosophers that call themselves compatibilists, which means free will can coexist and is compatible with determinism. So even though you have a computer which is undoubtedly, unquestionably deterministic, you can argue about whether God is deterministic or not, but no one will question that computers, the way we build them today, are deterministic, okay? So, said, within this determinism, there is still a compatibility between free will and what is determined, or the knowledge that is contained in a machine. Okay? And the most prominent philosophers in this category is Daniel Dennett. He's saying that free will and determinism are compatible. Freedom lies in acting according to one's reasons and values, even in a causally determined world. It's a beginning of a resolution, but not entirely. I'll try to elaborate on that because it requires some refinement. But I'm a compatibilist myself, so I believe computers do have or could have free will, and we'll have to be more accurate or more precise in explaining how. There is an anti-compatibilist school of philosophy, influenced by important experiments done by Libet in 1983. He's a neuroscientist, and among them we have Sam Harris. Sapolsky has a new book declaring there's no free will. Yeah? We shouldn't even put people in prison because they are not responsible for their action. Okay? Almost explicitly saying so. Okay? So it's only an illusion. And the experiments are interesting. We find out that there is a time delay as much as half a second between the what they call a preparation time. The brain inside, the subconsciously decided to act, and the people perception that they have made a decision ready to act. Okay? A half a second. That means that the subconscious or the neural activation, okay, is making the decision for you, not your rational and cognitive thinking, but what's going on beyond the consciousness. So when you think you made a decision, no, it was made before, half a second before that. And the idea, the way it connects with free will is by people arguing that the unconscious brain activity precedes the conscious decision making. So free will operates at a higher level of cognitive control. You get the illusion that you made a decision, but essentially the decision was already by neural activation beforehand, and the only thing you do is has sometimes the option of vetoing or rationalizing why you did it. So we come later after a decision is made in our nerves, and we say, the reason I did it because I wanted to pacify so-and-so. Okay, so be aware that there are philosophers today familiar with neuroscience, familiar with computers, still arguing that we have, that it's all an illusion. I'll go now into a related scandal. A related scandal I call counterfactuals, and which has a similar problem here, similar conflict. If everything is predetermined, how can we talk about the road not taken? I take an example. I've taken aspirin, okay, and my headache is gone. What if I didn't take an aspirin? You took an aspirin, which means you are the kind of guy that was forced by neural architecture to take an aspirin. Okay? And first of all, what information would you get if you know that if you didn't take aspirin? Who cares? And second is, how can you talk about it? It didn't happen. How can you talk about things, worlds that did not exist? And what can you learn from the world that do exist, the road you did take, about the road you didn't take? Okay? So this is a related scandal, but fortunately, we solved it. At least I'm satisfied that we solved it. Okay? And this is how it is resolved. Okay? Here's an example. What if the train, not only about your action, about events. Okay? What if the train left on time? Would I have made it to the meeting? What would Joe's salary be had he not quit college? Had he spent one more college year? Okay? And these are important questions that people are spending their career on. Okay? The relationship between education and income. Okay? In medical field, in science, everywhere, counterfactuals are the building blocks of our scientific thoughts. I dare you to read an article in the New York Times that has at least 20 counterfactual relationships. Okay? That's how we explain things. And doing an observed event requires changing the laws of physics. Right? Because I'm changing the law of physics, and I said, what if the train left on time? It didn't leave on time. Okay? And if I want to speculate about what if the train left on time, I'm working in a different universe, different world. So what kind of laws of physics should be violated in order for me to figure out what will be the case, what the future would be? And the answer is very simple. So here I'm going to give you the answer in one line. Okay? The answer is, I'm pressing the wrong thing, but I have a recovery button. If you imagine that reality is a society of listening variables, namely it's a collection of deterministic law, M is the model of reality, and all we have here is a collection of functions. Okay? So every variable has a function fi. I should do that. Every variable vi is a function, different function for every variable, yeah, of other variables in the universe, yeah, okay? And then we can ask, so what if the universe were different, and what will be the outcome y had x been 0? Let me first convince you that it's a reasonable perception of reality, okay? That the temperature of this microphone takes its value on the basis of all other variables in this room. Okay? The speed of the molecules from my mouth, the radiation that comes from this bulb. Okay? So it listens to everything else. I know it's complex, but just imagine it. Okay? I didn't say that the number of variables is finite. But we know that the temperature of this microphone does not depend on the stock market in Hong Kong. Right? So it has a finite number, smaller number of variables it listens to than the entire universe. Good. But suppose this is the basis of reality. It's a deterministic function. No quantum uncertainty. Okay? Can we ask if this is a perception? Can we ask about take any outcome variable, y? Ask what would y outcome be had x, some other variable, equal to 0? Right now we don't know what it is, or we know it's 1. Okay? I'm using subscript to designate the counterfactual, not condition, but subscript. Can we do that? And the answer is sure. It's easy. It's embarrassingly easy. The answer is being I call it the first law of counterfactual, and it goes like that. What y would be had x been different, say 0, is equal to what y is, where in a mutilated model in which the law that currently governs x is replaced by a new law, x equal to 0. Can you imagine anything simpler than that? So here's the answer. Y would be, y, the value of y, had x been 0, is equal to y in a different model of the world, in which you replace the law that currently governs x with another law, x equal to 0. It's a nice law, right? X equal to 0. Here's how it goes in using graph. Yeah. Here is a perception of the current model of the world. You can see that x is currently governed by W1 and Z3, and y is governed by all this. Good. We want to find what y sub x is. Namely, what y would be had x been equal to small x. Easy. Cut down the arrow. That means remove the function from the model. Currently go into x, and you have a new model. In this model, compute the value of y. Solving equation is easy. Every high school kid can solve equation. So that is the reason that I say that counterfactuals are embarrassingly simple. And so this is resolved. Okay? And I hope I can convey you there is some relationship between resolving the problem of the scandal of free will with the scandal of counterfactuals. We are not scared of determinism. Yes, we work within the deterministic world and our deterministic perception of that reality, and now we are manipulating things in order to answer questions about choices, about counterfactuals. We just have metaphysical entities. That is the name of the game. Good. Let's see if I can do it in here. And I'm going to go back to compatibilism in the context of machine determinism. Where are the options? I'm asking you, just imagine that you have a computer. Okay. I'll say it here. Consider a chess-playing engine. I'll ask the question first. Every step of this machine is determined by the code. The code is a 12-line code that tells you the rule of the game and tells you how you should play the machine. Okay? So that every step is determined now by that code. Where are the options? Do we have options? Suppose you look at the board position and you say, which move should I take? Okay. Is this a real question for the machine? The option to be taken is determined by the initial code. It determines on the, you don't even need to look at the past. Just look at the board position. Okay. So we know that for any board position, you have options, right? You have moves. You can move the knight, you can move the rook. But there's no option in terms of the machine code, because every step was already predetermined by the code. Even when you wrote down, even if the code contains, pass it through some heuristic search algorithm, do alpha, beta, and look 5 moves ahead. All this is predetermined. What you do next is predetermined by the code. So where do the options, the idea of option, emerge from? Where are they stored? Well, let's look at some issues here. We have to distinguish implicit from explicit knowledge. Implicit knowledge is the rule of the game of chess. But it's totally different from explicit knowledge. The implicit knowledge determines what the best starting move. It determines for every board position whether it is a draw, a win, or a loss. It's determined. It's hard to compute. Chess was not solved. Checker was solved, by the way, but not chess. Okay? So I'm moving here from indeterminism to complexity of computation. Theoretically, it can be solved if you had the time and to explore the search up to the checkmate. Okay? You can assign every board position a label: win, draw, or loss. Okay? But it's totally useless because you cannot go to infinite horizon. You must limit yourself to a finite horizon. And you do all kinds of heuristic tricks. So let me go and summarize it. All steps, namely moves, are predetermined by the master program, the code. There are no options there if you look at it from the implicit knowledge. But explicitly, what do we have when we play a game of chess? How is it programmed? You have move generation, you have search algorithm, you have evaluation function, you can have even learning, like a Samuel learning program, okay, where you use regression to find the right coefficients into determining the strength of a move. Okay? Plus, you have openings and endgame database, and on that basis, we come out, and the options are very clear. Are the moves that you can make according to the rule of the game. So when you're talking about the explicit knowledge, the one that actually drives the algorithm, there it makes sense to talk about options. Determinism applied to the implicit, and determinism is true or holds when you talk about the implicit level, the master code, while choices appear at the explicit sub-program level. Shall I go to the brain now? I don't know if I have this audacity, but I'll stick with the computational aspect of the illusion. We haven't resolved it completely. There are certain questions that we still need to understand. If free will is an illusion, why did evolution labor so hard to endow us with it? What is the survival value of it? Should we program the next generation of computers to communicate with illusions such as credit, blame, guilt, regret, and attribution? Would robots play better soccer if equipped with credit and blame vocabulary? I'm not kidding, because one of the important advantages of this vocabulary is communication. So I bring an example in my book when the coach tells you, hey, you should have passed the ball to Charlie, and you didn't. Okay? Therefore, you are going to be out of the next game. What does it mean? You should have. Okay? You should have means I do not have access to your decision-making process when you are under the heat of the game. Okay? You see so many factors. You see Charlie and Joe and Shmo and so on, and people are running around, but you have access. So if I tell you you have done things wrong and you should have passed it to Charlie, you are the one who knows your decision-making process more than me. So you should prioritize reset your priority inward, and next time you play it differently. And I'm not telling you how, because I don't have access to your reasoning process, especially the reasoning under duress, under pressure. Okay? So I'm telling you, you should have passed to Charlie, and you didn't sit on the bench. What softer processes should ordain? Oh, yeah. As I started this talk, I talked about the very clear sensation, very vivid sensation we have that we do have an option. Where did it come from? In our brain. Okay? So we talk about computer, okay? And we're not talking now about chess, where the options are determined by the rule of the game. Okay? I'm talking now about things like aspirin. I'm sorry. Let's talk about computer. Any decision that you make, any game where you don't have, where the rules of the game do not identify the options. Where do they come from? And what are the processes by which we declare a certain action willful? I did it by free will. And other actions spontaneous or thoughtless. For instance, if you are in a habit of taking aspirin every time that you have a headache, you take them automatically without even thinking. Okay? So what is the process by which you distinguish between willful action and spontaneous action? Yeah? And where is it stored? Normally we store it, and how do we distinguish them? And where do we store the label? Meaning that normally we look, if we had to pass that action through some evaluation process, it leaves a trace in memory. And you can say, yes, I thought about it. So you look at your short-term memory, yes, I've given it some thought. I passed it through a search algorithm, and I looked at the consequences. So that leaves, in other cases, it doesn't leave any thought, so we should still clarify the process by which we distinguish between thoughtful and spontaneous action. And I bring an example here in my book where you hire a robot to clean, to serve as a cleaner in a house, and it makes noise, and you wake up the lady of the house, and we expect the robot to understand that the action will cause harm or discomfort for the lady. And instead of looking at the computational parsimony, it's involved by the lady tells him, you shouldn't have made noise, okay? Instead of saying, you can run the vacuum cleaner whenever I'm not home, or whenever you can muffle the noise, or in all possible situations where it is okay to vacuum. The number of those exceptions is too large to explicate. Instead, she just said one instruction. You shouldn't have done it. That's enough. At least we expect that that should be enough for the robot to understand why it shouldn't have done it, and when it is permissible to do it, when it is not permissible, to reason with cause and effect and come out with the right answer, understanding. I think I'm going to the conclusion slide now. I'm just going to repeat now what I said, but forgive me for repetitions. I hate repetition, but sometimes I cannot help it. So the illusion of choice is generated by explicating world knowledge into a BDI model. BDI stands for belief, desire, and intentions. Okay? This is a standard model for agency. Okay? But what is belief? What is the state of belief in a machine? I don't know. It's not statistics. It's not a joint probability function. Belief has to be include also what causal relationship and counterfactual, namely what I showed you there, the collection of listening agents, collection of listening variable, is my perception of a person's belief or an agent belief. And this I believe is missing in the work on multi-agent systems. Okay? And understanding that belief is not just statistics, but belief is a collection of listening functions. And survival of this illusion lies in efficient communication, team performance, and moral responsibility. The computational benefit of moral responsibility shows up in setting priorities, in efficient communication using world models, and purposely conversion of implicit to explicit knowledge. This is the key. Thank you. Okay. I'll be happy to answer any questions.
I have a question of your model where you have the mu's and the x and y. I'm wondering what's the relation of x to the other mentioned variable. It seems to be, oh, sorry. Can you hear me now?
Shall we do it, shall we put down, good.
The first one, like how are the mu's related to the x? It
This
seems
one.
Yes,
Correct.
these, how are these related to x on the other side?
Well, x is one of the variables, a name for another variable.
Oh, okay, yeah. So,
One of them, okay?
oh, one of the variable x, oh, okay.
Yeah, it may be vk, v sub k.
Ah, okay, I see. Thank you.
And y is also one of the variables. So I pick up one of them, which I'll call outcome.
Oh,
I'm in
okay,
it, like the income, okay? This is where my interest lies, the outcome. And I pick up one of the variable y, and I say, what would be the value of y had x been some other variable, okay?
Oh, yeah, I see.
Okay.
Thank you very much, I appreciate it.
So we ask, why do we need to be able to interpret with statements like, you shouldn't have done that. But when I hit my toe on some furniture and it's incredibly painful, that is really just a signal saying, you shouldn't have done that, with no further information about what choice was wrong. And so evolutionarily, don't all animals with brains making choices need to deal with exactly this issue?
The robot cleaner doesn't know that he'd done anything wrong. He was programmed to do vacuum cleaning, and that was done. Suddenly the lady said, you shouldn't have made noise, okay? Why? He didn't hurt his toe, he didn't see any harm to his body. But she tells him he shouldn't have done it, and now we expect the robot to understand when it is okay to vacuum and when it is not okay. Just from this simple parsimonious instruction, he shouldn't have done it. You woke me up. Parsimony, isn't it?
Thank you very much, Professor Pearl. Should we give a minute to Shuki for a reflection, if you'd like to say anything?
I mean, you can sing maybe now.
Questions. First, I want to mention, thank you, Yuda, for coming and bringing light to Caltech. You know, the logo of Caltech is a torch with light and a hand passing it to another hand. And I wanted to have someone today that will add to the light of this torch when we pass it to the next generation. I really appreciate the fact that you came and added to the light of Caltech. Thank you very much.
Thank you all for listening. Appreciate it. So,
Just
I said
go ahead.
that the sentence, I love ignorance, I know how you said, I love for ignorance. It's so deep that I really learn from it. And I keep on telling my students, the hardest thing is to define your question, not the answer. It will become easy once you define the question. And I've been trying to drive this idea for many years, and I find it harder and harder. People are not paying attention to explicating the research question they start the project with. What is your research question? In what format would you be satisfied? How would you measure your progress? Okay. The hardest thing is to define your question.
Yeah, I think we need to teach people to be comfortable with ignorance and celebrate it.
Celebrate ignorance, yes.
And to have an internal feeling when you understand something and when you don't understand something, and that's very hard to teach. I just want to make one small comment. First, thank you, Robert, for hosting
Thank you, Robert.
Yehuda. I want to share with all of you that Robert is an academic grandson of Yehuda, and Rina Dechter was a student of Yehuda. And now Robert, after doing a PhD with Rina, I was privileged that he joined Caltech and worked with me for a couple of years. So thank you
Yeah, I forgot to mention that Robert is my academic grandchild.
Yeah,